Yesterday we did. What happened? Somebody is there online. Everybody is present there once. Nobody is online. That's what the best thing that we are. So what do you have to do? You open your button, then you don't take anything. Body meter. No. What do you take? Right? In the morning, other mostly rice products. Any fruits, vegetables. How many people of your vegetable? No, you have to put your production plan for that. You have to consume it because it's not free of cost. But the thing is, you want to you have to make good catches. Oscar, this long you will take. How many of you are tired? How many of you are tired? I'll give some tablets. What is it? What is it? It's like for 8 hours. Any last class what we had studied? Huh? Partition theorem, right? Okay. What is Cartesian product? What is Cartesian product? Yeah. What is Cartesian product? You raise your hand, right? But I saw it. What is it? What is Cartesian product? What is Cartesian product? Not multiplication here. That is real. No, that is relation. Biology. That's what I'm doing. What is Cartesian product? What do you understand? In test, what I will do, I won't give any proper. I'll just give all the definitions. Write the definition of Cartesian product. Write the definition of R. That's our time. What? Yes, set of ordered bits. Okay, so suppose if I'm giving you two sets A, which has element 1, 2, and set B, which has element A, B, C. Write the Cartesian product. Write the Cartesian product. See, first element, okay, right, A cross B. Okay, write this Cartesian product. See, when I'm saying Cartesian product of A and B, that means A cross B will be right. Okay. Write down fast. Don't take this one. Done. Write Cartesian. How you will write a Cartesian product in set builder form? How you will write it? Huh? We can't write it. That's what you're saying. Okay. Let's do that. Do it. See, it's not just this example. Listen, everyone. Mushal Babu. It's not just this example you have to write in general. Suppose elements like 1, 2, 3, whatever it is. So these are A. Okay. You can write this as A, and here it is B. Okay. You can write like this also. So now write this in set builder form. How you will write this in set builder? How do you write set builder form? We start with what? Curly braces, right? Yes. Yes, exactly. A comma B. That's how, because it's the ordered pair, right? So first element, obviously, if I'm writing A plus B, first element is this, second element is this. First here. Here. When I'm telling you something, first either when I'm giving you problem, then you start doing it. That time you'll be looking here. I don't know why. So this is first element, second element, first, second, third element. And we are writing A cross B. It's A Cartesian product. It's not cross, sorry. A Cartesian product B. Then first element, that means this element will always be from set A, and the second element will always be from set B. Okay. So this such that A belongs to A, and we can write and B belongs to B. That's how we can write in set builder form. Simple, right? Write down. Any confusion, Sunshine? Anything? It's fine, right? And this A and this B represent this, the elements in this and the elements in this. Okay? It's not this B is not this B. I'm sorry, because I've used the same symbol here and as well as here. This B is not this B. This B means the elements present in this set B. A means the elements present in set A. Okay? Right. Done? Okay. Now today we will be studying relations. Okay, and this is really important. Okay. After this, we'll be studying functions. So I'm hoping to finish a relation today. So pay attention. It's not very tough. It's very easy, but it's a critical point in mathematics. See, whatever knowledge we have gained till now, we'll be studying on that basis. Okay, and in further classes, whatever we'll be studying functions or calculus, whatever we are studying, we'll be using that same concept. The concept will remain same. It can change. The values can change, obviously. Okay. All right. Okay, write down one. First do one. Let's do one or two problems from this. We have done problems from this, right? Cartesian product. Have you or not? Okay, just one. Let's say if A is equal to 2, 3. What is wrong with this? And B is equal to 6, 8. And C is equal to 1, 2. Okay, all right. Okay, let's write and D is equal to 6, 9. Verify A cross A Cartesian product B intersection with C Cartesian product D is equal to A intersection C Cartesian product B intersection D. Do this. Hopefully everyone can do this, right? Because you know how to take Cartesian product, you know how to take intersection. Okay, right? Kushal Babu. Yes. That good. Good. All. Kushal Babu. Do it fast. Raindrops. Biology. Then Kushal Babu. Done. What about you? All. Adi. Good. Cartesian product. You understood how to write in set builder form. Okay. How do we write Cartesian product in set builder form? It is clear. What is Cartesian product? It is clear. It will always be the ordered pair. Okay. And if suppose there are two elements in set A and three elements in set B, how many Cartesian product will get? How many elements will be there in Cartesian product? Is just a multiple. Okay. Clear? Everyone is done? Okay. We'll start relation. Shall we? What happened? Sunshine. What do you mean by relation? First tell me that. English definition. It's the same thing here also. Relation between us. We are friends, right? Relation between your parents. You have you till now we have understood relations like that only, right? Any two objects can have a relation between them. How? How? Tell me what you have studied till now for that point of view. In physics, have you studied something like a gravitational force between two bodies, right? Between two masses, you have studied, no, in 10th standard. And in 8th also, I suppose you have studied that. Yeah, so one body, other body, they have a relation. These relations can be defined between the span and us. It can be defined in any manner. Okay. That I suppose I don't have to explain that. Okay. Now let's say we have relations. We have a Cartesian product. We have two sets. First, understand we have two sets. Set A and B. Okay. We have A and set B. Now we can take the Cartesian product of these two. Fine. We just learned how to write it, and you guys are absolutely phenomenal in writing this Cartesian product, right? You can write all the Cartesian product, right? Okay, very good. Now let's say A has some elements like 1, 2, 3. It's the simplest example, so I'll take it A, B, C. Okay. Now let's write the Cartesian product of A and B. Okay, write down, everyone write down this. You'll be saying, okay, why you are repeating everything? You'll do it, believe me. Write A cross B. A has element 1, 2, 3, B has element A, B. Just write it down. I'll also write with you guys. Fine. Now you see there, here, everyone done? Now this first element, this first element belongs to what? A. That's how we write a Cartesian product in set builder form. This we can write. If suppose this is X, so let's say this is first one is X, second one is Y. So how we can write X comma Y such that, or you can put a semicolon or colon, it doesn't matter. It's fine. Let's write like if your book. X belongs to what? Set A and Y belongs to set B. This also we have already seen, right? This is how we will write in set builder form, and we have already defined the set of element of A and B. Now a relation. Now we can define a relation between A and B. So A and B we can define any relation. Okay, like suppose relation. Let's say R dash. For R dash, I'm writing for a relation. I can define any relation. Like how you can define a relation from A to B. A to B, how you will define a relation? Just define like all the elements of set A, or it's a little hard to understand. Let me give an easier example. I'm sorry for this. Like suppose A has 1, 2, and B has 4, 6, and 8. Let's say that. Okay. Now I'm defining a relation. Now we can have a Cartesian product A cross B, right? I'll just write it 1, 4, 1, 6, 1, 8, 2, 4, 2, 6, and 2, 8, right? This is the Cartesian. See, we can also define it here also. I just want you to understand it properly. Okay, one example. So this is the Cartesian product. No problem here. So far, everything is good. Okay. Now I'm defining a relation R dash such that R dash will be equal to X comma Y such that Y. Okay, such that Y is equal to 2X. I've defined a relation. This is the definition. Y is equal to 2X and X belongs to A, Y belongs to B. This though already we had written before, right? The Cartesian product, but here you see this is the relation. This is the relation that I'm defining between A and B, because what? Why it is not correct? I will write it, don't worry. I haven't finished it. Okay. So all the elements, that means what? Y is 4, 6, 8, and the X is what? 1 and 2 only. Fine. Now, what set here satisfies this? Is there any set that satisfies this? Now, if Y is equal to what? Like if you take this 4, right? 2 times of 4 is what? 2 times of 4 is, sorry, 2 times of 2 is 4, right? So here, if you multiply 2 with 2, X is equal to 2. So you will get Y. So there is only one element of this A cross B which satisfies the relation, right? So relation, how you will write? This is equal to this is the set builder form of relation. Okay, this is the given. See here, DAB. See here. This is the set builder form of the relation. Okay, and just this part, if I hide this part, this is A cross B. Right? Now, if I write in terms of elements, so you have only this element 2, 4. Okay. This one. No one else satisfies. See, 2x, nobody satisfies. If y is 8, 2 into 2 is 4 only, right? So it cannot be 8, it cannot be 6. 1 into 2 cannot be 4, 6, or 8, right? That means only this element, this point, 2, 4. Only this satisfies this relation, the given relation. Y is equal to 2x. Understood this thing? Is that means what? Now you see this relation is what? R dash. This is the relation. Okay. Now this set is a subset of this A cross B. That means what? We can write R dash, a relation, is a subset of Cartesian product. Always. Okay, that's what we can conclude from here. So the relation, any relation, is always a subset of Cartesian product. Okay, Cartesian product of those two sets, or if there are three sets. It depends, because here we are only taking two dimensions, x and y. Okay, you can use other variables, a, b, it doesn't matter. That means a, you will write here a belongs to a and b belongs to b. That's what you have to define. This you have defined what is x and y, because in the problem it's not given x and y. You are just defining it like this. Understood this thing? Anyone having any doubt at all? Raindrops. Any doubt? DAV, hurry. Pakka. Understood. So you have the Cartesian product and you define a relation. That's it. It can be anything. So we'll do some problem based on this relation and it will be there. Okay. Hopefully, so write down relation is always a subset of the Cartesian product. Cartesian product of the given set also. And if you want to get the precise definition of relation, you can see your book. But what I have said, what you have understood here, the relation is that only. From one set to another set. Mostly will be in your entire 11th standard will be studying for 2 sets of. And in functions, it will be x and y. When we'll have the graph and everything, we'll see. There will be different types of functions. How many of you have finished functions in your school? In your school, functions over. Okay. Have you studied one function, 1-2 function, on 2 functions? Have you studied those things? CBSE, they don't teach it, right? Yeah. So you'll be like, what? There is something called yes. First, understand the relation. If you can understand the relation, function is again you will see that function is a subset of relation. Okay, we'll see that. It can be anything. You can let's define here. If I have, this is just for the convenience, I have defined this relation. Let's do that same problem here. Okay. Now what I'm saying that you are given that same set A and B, these two. All right. DAV, pay attention. Now I'm defining a relation. Y is equal to x square. I'm just defining a relation. That's it. Now write the relation in set builder form. Write it down. You are given A. You are given that same thing. No, wait. I'll write A. 1, 2, 3. B is 1, 6, 9, 4, 12, 16. Okay, it will be too much. Yeah, you'll keep writing the sets, so I'll just delete some of it. Let's forget this. And show that your show that your relation is a subset of Cartesian product of AND. Some problems. I think the connection for this. Yeah. Yeah. Usually it is defined, usually we write R, okay, for relation. You can, because R we write for real numbers also, right? So that's why I'm using R dash. You can write anything and you can write that is the relation. That's it. You can write alpha, beta, gamma, theta, whatever you want. That is fine. Right. It is fixed, right? It will not blink now. If it will blink, again I'll come. Done. Come on, do it fast. Done, Shalshan? Where is the separated form? Write down the separated form. And this is not by your accordance, but okay, you have also value x. Okay. You need another. See, right now when you are writing stacks, you are writing. Okay, let's see. Let's see the solution. A cross B, can you guys tell me what is A cross B, the Cartesian product? Is as it is 1 1 1 6 1 9 1 4, right? All the elements. So I solve. Okay, fine. Now according to this relation, that the relation that we need to define it here. So we write R dash. What will be R dash? What? So this is set builder form. Such that, or y is equal to x square, because this is already the given relation. Yeah. X, where x belongs to A and y belongs to. You can put a comma, it doesn't matter. It's fine. Completely fine. Arif, you got this? This is how we write the set builder form. This is called set builder form. I think you were not there when we were studying set builder. So, but it's very easy. You can just go and have a look in the, I think first topic is set builder and tabular form, right? List form. That is called roster form. Both are different. Set builder is different from roster form. That this is the roster form when you are writing across this one. Okay, the list, right? Correct or not? Please correct me if I'm wrong. Okay. Now tell me, write down this in list form or tabular form or roster form. 1 comma 1 2, 4, 3, 9. How many of you have missed this thing? 1 square is 1 only, right? And it is present in both the elements, both the sets. Don't do that. Please don't do that. You're not a kid anymore. You are in higher secondary school. Not secondary, higher secondary. No? So you'll be thrown from higher altitude. Anyway, this is clear. Okay, now see. Now there we'll study this same relation in form of pictorial diagrams. Okay, or mapping we also say. So let me write it here. The same example will take mapping. What I can write as pictorial. Pictorial representation or diagram, whatever you want, you can write. Pictorial diagram or representation, we should write. Any problem? Shall I write it complete? I won't do that. Pictorial diagram or mapping. Set or you can say mapping. Or you can pictorial representation or mapping. That's what we say. This one. Now we have what we have. We have two sets, right? A and B. A. Fine. That's oval, circle, whatever you want, you can draw it. Okay. Before that, I forgot to mention this thing. It's fine. Suppose this is your A cross B. Fine. This. I just something is wrong. I have to ask them to give iPad, not this stupid tab. A cross B. Fine. Now A cross B is what? DAV. What is A cross B? Hey, wait. What is A cross B? What do we call this Cartesian product of set A and B? What happened? Show me your face. Huh? Show me your front yard. Show me. Very happy. What happened? Something funny. So blinking itself make you laugh. You guys are awesome. Yeah. Now, if I want a relation, we know is a subset of this. So relation will always be somewhere here. R dash. Fine. Relation is a subset of A cross. I just wanted to draw it in a pen. That's what I wanted to do. And you guys are so smart that you already know it. Okay, so this is that R dash here. And this is A cross B. Because see, A cross B can have how many elements here? It will have 1, 2, 3, 4, 1, 2, 3. 12 elements you will be having here in A cross B. Why am I saying cross? A Cartesian product B. That's why you guys are also doing this. I'm really sorry for that. Because usually we write no A vector cross B vector. So yesterday I was teaching vectors, so it's there. What A Cartesian product B. Okay, and R dash is a relation. So R dash is a subset of A cross B. Because R dash has how many elements? Only 1, 2. All right. But how many possible elements can R dash have? Okay, we'll study this part. First, let's study this pictorial representation. Now, in A, let's say what was the elements 1, 2, and 3. This is what we had, right? And in B, what we had 1, 4, 1, 4, 1, 6, 9, right? That's what. Now we have a relation between A and B as this. 1 is related with 1. The given relation, what it was there. And 2 was related to with 4 and 3 with 9, right? So 6 is left alone, right? 6 is lonely in this world. Okay. So and this is only for this problem, not if I just change the relation. If I just change the relation, that it can be different. Okay. I can change the relation, right? I can just write y is equal to 3x. that's what I change the relation. So it will be complete. This arrow will be completed. So this representation is called your pictorial map. Okay, or pictorial representation. That's what we call this one. It's easy, right? Mapping from one A to B. Now, this was very easy. Okay, very good. Now there is something called image. Okay, image is, see, the image of 1 is 1, the image of 2 is 4, the image of 3 is 9. I have words. I cannot say, I'm not allowed to say. Anyway, so we say 9, 6, not 6, sorry. That means if we say that the elements of set B is Y and elements of set A is X, that means Y is the image of X. Y is the image of X, whatever the values of Y we are getting here for this problem. Okay. Yes, image cannot be this part because it is related to not A. Okay. One more thing I almost forgot, that A cross B is not equal to, not cross Cartesian product. B Cartesian product A, right? It's not, because first element will be 1. It will change the element, right? So A cross the A Cartesian product B is not equal to B Cartesian product A. Yes. If A is equal to B, then it is true. Like the mapping from A to A, right? There can be a relation when you map A to A, A to A. So 1, 2, 3, 1, 2, 3. This is because A has that 1, 2, 3 elements, right? These are the elements present in A. So obviously you will be having these elements present in B. But A square now if you define Y is equal to X square, now you are saying this element is Y, the second element is Y, and the first element is X. So A to A mapping only you will have this one for this problem, for Y is equal to X square. For this relation, okay, slow. Y is equal to X square, we have only this 1, 1, 2, 1, 2. So one is related. One is related with this one only. Okay, because 2 square is 4, but 4 is not present in A. 3 square is 9, but 9 is not present in A. We don't know about B because we have to define a relation from A to A, not A to B. Okay, just write it down. So also, I don't think the problem is that one thing is this just not listening. Relation is, we understand relation, right? Relation is a subset of Cartesian product. You know how to write Cartesian product? Okay, I think you can write that. It's easy, isn't it? It's easy. Okay, Bhaskar, for today, like let it be like that. But next one, next time, because it's on that post problem, right? This was happening last class. So just ask Raghav not to change. I think you have to change the laptop. Yeah, all make sure. Yeah, because I think chemistry also you face the same problem, right? Oh, okay, all right. Thank you. Okay, so image is clear. Fine. Where is that? Again, we have to write a new example. Anyway, let's write. So this is A, B, and we are defining a relation 1, 2, 3. Let's write some other example, right? 1, 3, 4, 9, 10. Is happy with 10. Now, if I'm giving the same relation, y is equal to x square. That means what? You can map 1 with 1, 2 with 4, 3 with 9. Right? Yeah. Yeah, you can do anything. Anything. See, it's the problem what it is defined. I'm just saying for this problem, just for your understanding. In maybe in your exam, it can be a different problem. Okay. So if the important thing is to understand the mapping from A to B. Okay, how do we write it? So here 1, 4, and 9 are images of 1, 2, and 3. So image is clear, right? Now there is something called domain. Okay. What? Why are you laughing? Something funny about domain? Tell me, we'll also laugh with you. Okay. No need to say sorry all the time. See, if I can joke about it, I can make a stupid joke. Of course, you guys can make a joke. Like, it's not mandatory to sit calmly or quietly in the class. You can shout as much as you want, but don't do that. Okay, so what is domain? Domain is all the set of values of whatever is defined. 1, 2, 3. This is the domain. Okay, so domain here is set of values of this element, this set. Okay, so it's in that, right? So 1, 2, and 3 will be the domain of this from this mapping. That means all the elements, yes, all the elements of set A will be your, because we are mapping from A to B. Okay. If any one element is like, it will be left only in B. It will not be left in B. See, any example, if even if you take, yeah, of course, suppose there is 2. Okay. If 4 is there and it's not present in here, it is left out, right? But domain will all will remain this complete set. 1, 2, 3, 4 will be your domain. Even if you don't relate it, okay? We'll study about some. What is that part called? We'll study about that also. First, write it down. I'll just give you the definition of domain. Yeah. What you are saying? What you don't know, this domain is, the domain for this set will be set of all values of this set. That means you write how you write set form. Write it down. Now suppose we are saying this is x. We have assumed this to be x and this is the y. So set of all values of x. That means domain will, yeah. Yeah, suppose 4 is here. 4 is here, right? And there is no 16 present here. Fine. But domain will include all sets of elements. So x. What? What? Tell me, tell me. You have studied something different. Huh? What you have studied? That, why? See, in range we don't include. Just follow me here. Okay? Do it here. If I'm wrong, I'll definitely thank you for correcting me. Wait. No, it's fine. Just give me a moment. Huh? What you are saying? Four is not defining speech. That will not belong to the. Just give me a moment to think about it. How many of you have studied that? How many of in the book it's given in the book? Is it? Because because we are having a certain relation here. So according to that relation, it may not fall in the domain. Okay, I'm getting it. Okay. Got it. Fine. So it is not necessary that if suppose 4 is also a point here and it is not defined. That means four is not defined there. Okay. If not defined, then 4 is not 4 will not belong to the domain. You are right. Thanks. 4 will not be the domain if it is not defined. Understood? You are getting confused? Or if you have any doubt, please tell me. Now you understood, no? See. Why? What happened? Shall you come sit here? 4 will also be included in the domain. No, it won't be. See, if 4 is not defined, listen. I'll explain you. In functions, will explain it. See, all the domain is a subset of the set A. Okay, if 4 is not defined, then 4 will not belong to the domain. Okay, I hope I'm right. 4 will not belong to the domain. Why you are saying that it will belong to the domain? See, that's what I'm saying. No, if 4 is not defined, see here 4 is not defined according to this relation. So 4 will not belong to the domain of this Cartesian product, the ordered pair. Okay, now what is range? All the values corresponding to this, the images that you are getting, right? Images, what you are getting, 149, right? So these are called range of, what is this? Okay, let's write domain in first set builder form. So domain is X, right? Because we are representing the elements of A as X, right? X in what? X comma Y, where X such that, okay, this is not semicolon, this will be X such that X comma Y what? X is related. That means you don't have to write this relation. You just need to write X belongs to a real number. You can write that, or X belongs to the relation R dash. Okay. X belongs to the relation R dash because we are defining this relation there. Okay, so that's how we write domain in set builder form. And range. Range is all the images that we learned in before this. We learned what images like 1, 4, and 9 are the images of 1, 2, and 3. So range will be all the values of y corresponding to the value of the domain. Okay, so write down range will be the what images of, just write down what images of corresponding value of this set B. In set builder form, how we can write? So this is y, x comma y, where y belongs to R dash. The relation what we have defined. Is this thing clear? So range is what? 1, 4, and 9. 3 and 10 will not come in range. Okay. Why? Because why 3 and what? Yeah, these are not images of 1, 2, and 3. The domain. See, range is always the image of domain. You can write in short, put a star mark and write range is the image of domain. Right? Understood? Any other point that we are missing? Okay, there is something called codomain. Now, first write domain is a subset of A. So let's write D for domain is a subset of not belongs to subset of A, and range is a subset of B. Okay. All right. Now there is something called codomain. Now codomain is all the values of set B. All the elements of set B will be your codomain. All, whether it is included or not. Even 3 and 10 are also codomain. Okay, DAV. 3 and 10 also are included in codomain. That means range is what? Subset of codomain. Write down. Domain I just explained no here. Wait. Yeah, the domain is a subset of this first. Yeah. This. See, domain is a subset of A1, right? So that's what you are saying. No? The codomain, you want a relation with codomain. See, there is no direct relation of domain and codomain. Okay, you can say that codomain array. See, this part is your codomain. Okay, this part is your codomain and this part is your domain. So the only relation that is defined is the Cartesian product. Okay. Other than that, there is no direct relation between domain and codomain. If you are not taking the images, there is no relation with the codomain. And range is a subset of B. That is B itself is a codomain. Okay. So that means range is a subset of codomain. Just write down with the star mark. Range is all the values of, how do you define it? So anyway, just write down all the values of y. So y such that x comma y. What happened? Y A cross B. Not A cross B, sorry. Y belongs to B. This all the values of y is equal to B also. Because you can write like this also. Y is equal to B. But B, since B is a set, we don't write it like that. Okay. So that's why we are writing belongs to. Because B is a set, it's not a element. Codomain, you understood? What is codomain? See the difference here. If X belongs to the relation, Y belongs to the relation. Okay. But if the relation is not defined, there is no domain, there is no range, there is no codomain. Okay. there has to have a relation between set A and set B. All right. So codomain is what? And also write down range is a subset of codomain. I'm writing in short. Just write properly. This one. Range is a subset of codomain. Okay. But still confused? Anyone is having any doubts? All the elements of is just called a means what first set. It is just called first set. There is no particular term about just all the terms of it. For B we call it codomain. Okay, for A we don't have as of now. I am not aware of it. If it is honestly, I'm not aware of it. Okay. And range is actually important. Okay, range we'll see in functions why range is so important. Understood this thing? Shall we do one problem? Hopefully. Okay, determine the domain of elements of the range R defined by R is equal to, I'm giving the relation, definition of the relation x comma y, not x comma, it's right. Such that x belongs to 0, 1, 2, 3, 4. Okay, good. Good question. Yeah, please then. Sorry. Alright? Okay. See, this is the relation defined. You have to find domain and range. Find domain and range. You can do that, right? First, write the relation. This is in set builder form. See, the relation is in set builder form. You have to write in tabular means that list form or roster form. You have to write it down first. How you can write it? Relation from A to B. What is A? What is B here? We have studied x and y, right? Here this is x, but and this is y. Right? Y is defined as x plus 5. I'm not defining it separately. I could have written it here x comma y such that y is equal to x plus 5. Okay, I'm cutting off that part. I'm just writing it here. Just do it. And x values you are given, so you can find x plus 5. Do it. Do it. Done. Okay, tell me the domain. 0, only 0. And range. X. Wait. How? What we don't have? Wait. Now see here. I have explained it. I have explained you this thing. X comma y. X y is equal to 5 plus x, such that x belongs to this 0, 1, whatever it is, till 5. That's how I have explained it to you. I have not instead of writing, so you have to write the ordered pair first. First write the ordered pair, first write the relation in that form. Then you will understand what is which is which one. Write down. You done? Yeah. Yeah. always the first step is to try to order. It's not like you have to do it by hours. I usually do it because all we learn from elements. See, you don't have to like create. So, first you have to write the relation. Okay, you can use the moving because these are the elements. These are the elements. Because domain is a set of marks, right? Range is also a set of marks. That's why we are writing. The range is 5, 6, 7, 8, 9, 10. That means everyone is plus. Okay, let A is equal to 1, 2, 3, 4, 6. Okay, and I'm saying that R is a relation from A to A. Okay, R relation defined. Okay, let me write it. Let me rephrase it. Okay, I'm defining R as A comma B. See it properly. Okay, then start solving. Don't just copy it. Comma B and such that A, B both belongs to A. Okay, and is exactly divisible by A. Understood this thing or not? See, first you are given set A. Okay. Now I'm defining a relation. You can write R dash or R, whatever you want. R dash. A relation is defined such that A comma B. Now where from B is coming? Okay. So A and B both belongs to A. Okay. That means you are not given A and B separate sets. Both sets are A on. Okay. So element of this is how we define this the Cartesian product, right? Cartesian product we write like this only, right? Huh? Oi, sunshine. We write like this, no? A comma B means X comma Y. Huh? And A, B both belongs to set A and is exactly divisible by A. You have to define B such that it is exactly divisible by A. Good. B is exactly divisible by A. 4 is exactly divisible by 2. This is equal to 2. That's that you are not getting any decimals. Yeah. This you are asking. Wow. You have to find domain, you have to find range, you have to find codomain. Okay, I think I missed B here. I said no, B is exactly divisible, but I have not written it there. So B is exactly divisible by A. Yeah. Got it? Tell me, R dash. 1 comma 1. Okay. 1 comma 2. Anything else? Correct. See, first element is B. First element is there. Second element is B. B should be exactly divisible by A. 1 can be divided by 1, 2 by 1. So she is correct. Now you have defined the relation. This roster form, whatever it is written, this what form it is? Set builder form. You have written this in roster form. Okay. Now what do you need to find out? Domain. What is domain? Huh? No. Domain and range are same. Domain is 1, 2, 3, 4, 6. Okay, a range is 2. Okay, 1, 2, 3, 4, 6 is also coming. Can you? Yeah. Domain is also 6. Range is also means 1 to whatever the elements are given. And can you represent this in mapping form? Can you draw the map of this relation? So let's say domain. Domain of what? Domain of the relation R dash, right, is equal to first element is A, because first element is your domain A, such that A comma B. Sorry. Why do I have to do that? A comma B belongs to R dash, right? Range. See, the range of R dash is B, right? Such that A comma B belongs to R dash. That's how we write domain and range in set builder form. DAV. That's how you will write domain and range in set builder form. I'll just keep repeating so that you guys should write it all the time. If somewhere I have made the mistake, please let me know about it. I can make it. I know that. I know myself. So yeah, so we're done. Images you draw. You're done with the image. That is all the elements of this set A. How many of you have drawn like this? Like 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. What is this? A, right? What is this? There is no B. And a relation is defined R dash. You can write like that. There is no B. That's why I asked you. I know you can do that 1, 1, 1, 2 with all you can represent it. There you will make the mistake. And you do it with all. I'm very much sure that nobody is going to ask you this mapping in your exam because nobody wants to see that, right? Yeah. You have doubt. So domain range clear. Okay, let's do one more problem. What? You don't want to do it? See, domain and range are really important. That's why we are solving a lot of problems in relations. Okay, do you guys know how to write in tabular form? In table form, how do we write? Okay, write this problem. How can we write this in tabular form? Let's see that. Let's see what. So A a relation of A to A we are writing, right? So here we'll write, we have what elements we have in A? 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. A to A relation we are writing, right? So this is R dash, relation from A to A. Now, is A corresponds to 1, right? So you'll put a 1. A corresponds to 2, 1. See, it's binary. In binary, we write if A do not belong, if the range is not something, so we will put 0 there. Okay, so this problem is not good for writing. Write down a different problem. Understood now? How do we write it? Let's do a different problem. There it will be clear, because this problem we cannot do it. Solve it. Write down let A is equal to 2, 3, 4, 5, 6. Okay, write down a different problem. Scratch this. I'm sorry. Okay, let's draw the diagram. This is also not. I don't know. Let A is equal to. This is also not. Wait. Let A is equal to 1, 2, 3, 4, 5. B is equal to 1, 2, 3. What, right? Ask Gulshal. 1, 2, 3, up to 67. Yeah, I know. So that means you understood. No, you don't have to write in list form. You don't write that. If it is this big, that means you have to write on set builder form. Okay, or the relation. Okay, if a relation. Okay, if a. Okay, write down if R be a relation from the set A to the set B. If R is the relation from A to B or R dash, whatever you want. Calling someone, some messages. Oh, it's already. Oh, wow, wow. So we have to leave. This is the last problem. This is our homework. Hey, you have to tell me, no, it's already 8 o'clock. I've been. See, the thing is, I never noticed the time when I'm taking class. So it's you guys will have to tell me, sir, stop, enough. Okay, these are the keywords that you can use. Enough is enough. Okay, R dash. Okay, write on this problem. R dash be the relation from A to B such that number 1. A to B you have written, no? So write down is square root of, means B is the square root of A. Elements of set B is the, see, when we are saying that relation is defined from A to B, that means first element is A, second element is B. Right? So square root of first relation that you have to first relation is square root of B is the square root of A, and second is cube root of B is the cube root of A. B is cube root of A. Yeah. B is a cube root. You know cube root? That's how we define cube root. What? Square root we define like this. Okay. Now find domain and range. So this is your homework. Okay. From next class, you have to tell me, okay, time is up, because I have to do something. I'm also missing that. And I'll just go again. Range, domain, images, everything is there. Any doubt? Bye bye. Thank you so much. And you know, when 10 minutes on this, those who are coming, but right, just put 10 minutes. Okay, right, it's you guys will be coming tomorrow already. Or you understood everything other than to be come. So,